The last piece of vocabulary here we're going to do is average value. This gets confused with average rate of change all the time. And I get why that happens. They both have the word average, but let's just review. An average rate of change means what? Rate of change. Slope. Average rate of change is just regular old slope. An average value is an actual amount. And sometimes they'll say average value or like whatever the problem's about, like the average amount of whatever it is they're talking about. Do you get what I'm saying? Like in the context of the problem, they'll say the average amount of something. But if I give you a list of numbers and I asked you to average them, what would you do? You'd add them all up, divide by what you've got. Okay, so leave a little bit of a gap here. An integral adds up all the area. So a to b f of x dx, that's like adding up your list of numbers. If I asked you to average a list of numbers, that's you adding them up. Then you divide by how much you've got. So out front, we're going to put a fraction. And to divide by the length of the subinterval, you have to divide by b minus a. For example, if your subinterval goes from 2 to 7, do you get that that's a length of 5? You divide by 1/5. Like, or you're multiplying by 1/5, you're dividing by 5. Anyway, you know what I'm saying? It's what we just did. You just have that little fraction out front. That's the only new thing. Okay, average value. So let's try this one. Average value on the interval 1 to 3. So out front, you're going to put 1 over 3 minus 1. And if you're like, hey, Miss Cole, I know that 3 minus 1 is 2. That's fine. I still recommend you write it out. Don't be too proud to write it out. All right. Because if you subtract wrong, you're going to be upset. And then you would have integral 1 to 3 of that function dx. All right, so out front, that would be a 1/2. And then we're going to do our antiderivative. So what's your antiderivative of x squared? Good, 1/3 x cubed plus, and then antiderivative of 4x, 2x squared, perfect, such that 1 to 3. Upper boundary minus lower boundary, and we'll end up just leaving these alone for the sake of time here. But again, it's exactly what we just did before the lunch break. You just have that little fraction out front, and that's you dividing by the length of the subinterval. All right, so if you plug in 3, you're going to get 1/2 times, what would that be? 9 plus 18. And if you plug in 1, you're going to get 1/2 times, what is that? 1/3 plus 2. So whatever that is, I'm going to just leave that as the answer. It's a perfectly acceptable answer if it's free response. All right, this one involves trig. Out front, you're going to have 1 over pi over 2 minus 0. And then integral 0 to pi over 2 cosine x dx. So let's talk about that fraction out front. First of all, pi over 2 minus nothing is just pi over 2. If you have 1 over pi over 2, that would actually be what? 2 over pi. You're going to reciprocate. All right, and then what is your antiderivative of cosine? You need a function, good, sine of x such that 0 to pi over 2, and then it's upper boundary minus lower boundary. So where is pi over 2 on your unit circle? At the top, that's 0, 1. Sine is the y value, so that would be 1 times 2 over pi. Minus, or what's sine of 0? You plug in 0. Yeah, sine of 0 is 0. All right, and then so that's your answer would actually just be 2 over pi then. All right, and then last one of these. What would you have out front? 1 over what? Four minus 1, good. Integral 1 to 4, 1 over 2x dx. So out front, that would be a 1/3. I would also pull out the 1/2. So if you have 1/3 times 1/2, That would be a 6. And then what's your antiderivative of 1 over x? You need a function that if you did the derivative, you would get 1 over x. ln, good. So ln of x such that 1 to 4, and we're going to end up just leaving this alone because without a calculator, I don't know what ln of 4 is. It would be 1/6 ln of 4 minus, oh, actually, you can do that one, though. What's ln of 1? ln of 1 is 0. Good. So actually, just 1/6 ln of 4 would be your answer. Yeah, good.
So if this was pre-response, could you just plug in x there for the different x's instead of solving down for that? So you just do 1/2, 1/3.
Are you asking if you could just take these, like factor these 1/2s out basically and put it out front?
No, I'm asking that we can just put the equation. So this, instead of solving this down.
Yeah, you could write 1/3 3 cubed plus 2 times 3 squared. Yeah, I just didn't have enough space to do that.
Okay.
I was gonna like run out of room if I did that. All right, and we'll just do this one because these are the same kind of thing. So use this graph of f of x. A is 2.3, so this little bump is worth 2.3. And then look, it says integral from -3 to 7, so that's the whole thing, is -7.8. The whole thing gives you -7.8. So that means 2.3 plus whatever b is gives you -7.8. And if you can do that in your head, you don't necessarily have to write it out. But if we add these together, we get -7.8. So b is going to be something negative, obviously, because it's underneath the x-axis. You would subtract over the 2.3. -7.8 and -2.3. Would that be -10.1? All right, so we have those. We're just going to use them to answer 4, 5, 6, and 7. Integral from 1 to 7. You should be able to answer them real quick. Like these should just go. Yep, -10.1. I like it. All right, from 1 to -3. Now look, from 1 to -3 means you're going backwards. So -2.3. From -3 to 7, but absolute value. So you want the whole thing, but you want to treat it all like it's positive. So it'd be 2.3 plus 10.1. Be 12.4. And then the last one is the average value. So it would be 1 over what? Good, it would be 7 plus 3, 7 minus -3. So that'd end up being 1/10 times the whole thing. So 2.3 and -10.1. Wasn't that given in the problem? We were given that, right? -7.8. That's not that bad. 1/10 of -7.8. If it's 1/10, you would just do what? Yeah, just like move the decimal point over. So -0.08. I'm going to go and fill this one out. I'll take the picture and post it. The only difference is instead of being given those numbers, you would have to slice this all up and find all these areas yourself and then add it all together. But I'll fill that one in and it'll be on Schoology if you want to look at it. Okay.